solving methods are concerned. In fact, the assignment for today is still going to be using the square root method in order to solve these problems out. But it starts to introduce you to this idea of when certain things happen as you're trying to solve. This is probably going to be new to you. We dealt with it a little bit in Algebra 1, but not really a lot at all. So this might be relatively new, but it will sort of pop up today as well as Thursday as we're heading through our solving methods. So a little bit of background before we go ahead and solve something. Tyler, I need you with me. Follow down. If I have the square root of a negative 4, this square root is asking you, what can I multiply by itself, meaning these two numbers have to be the same number, in order to get a negative 4. That's what that square root would be asking you for. So the only way that I'm getting a 4 is if I take 2 times 2, but that gives me a positive 4. But what happens if I take negative 2 times negative 2? I still get positive 4. Is there any number then that I can multiply by itself and get the negative 4? No. In fact, the only way to get that to be a negative 4 is if one of the 2's was positive and one of the 2's was negative, but then that's not by definition a square. Okay? So, because this can't happen, there is no way to multiply a square and get a negative. Can't do that. In Algebra 1, we would get to that point, we'd say I can't do it, so we would declare no solution and we'd call it a day. In Algebra 2, we head into this idea of, well, what if I could? So what we're looking at is, what if I adapt this square root a little bit? Let's do the square root of 4 times a negative 1. You learned last week that that's the same result as if I had the square root of 4 times the square root of a negative 1. Because if I have 2 square roots being multiplied, we just multiply their insides together. I get negative 4 still on the inside. I haven't changed anything at all. Good? So what's the square root of 4? 2. So the problematic part of this is this idea of a square root of a negative 1. We classify that as an I. In other words, we're marking this 2 as being what we call an imaginary number, because there is no such thing as the square root of negative 4. But I can go ahead and square root the 4. I'm just going to mark it as imaginary because it has a negative with it. Okay? Yeah, a lowercase I. I know my arrow kind of fell into it. So that once again, my answer to this particular problem would be 2I. That number right there is once again referred to as an imaginary number. Anytime you square root a negative, mark it with an I, you get an imaginary number. It doesn't exist. There is no square root of negative 4. If you try to do it on a calculator, it would yell at you, say there was an error. Okay? But for the sake of moving forward, we're going to mark it with an I to make sure that we're marking it as being an imaginary number. That leads us into our next sort of set of definitions. Can I erase this? Yes? So that moves us into what we call a complex number. A complex number is any number that can be written in the form of a plus bi, where a is equal to what we call the real part. That's a real number. And then the b comes with an I. So the b is what we mark as the imaginary part. In other words, the b is anything that came from that square rooting a negative. Still need to make sure that we're taking notes, going through that right. So if we look at the answer that I just gave you, that 2i, that is an imaginary number, but it's also a complex number. What could I write as the real part so that I would have have a plus that 2i? In other words, what is the real portion of that?
What's after the 2i? What is
An arrow. In other words, again, how can I write this so that I have something plus it, but I don't want to change it at all? Yeah. Yeah. I could write it as 0 plus 2i, which makes 2i a complex number because it can be written in this format. All right, well then the other one, we could do 3 plus, let's do 5i, just making something up. That is a complex number. What is the real part? What is the imaginary part?
5i.
Is the 5 because it came with a marking of an I. You could also have this with a minus sign in the middle. You don't have to have just a plus sign. You can have a minus sign there. But here's the other thing. Real numbers can also be written as a complex number. If I have the real number of, let's say, 7, once again, how could I write that so that I fit this complex number format? What would you think? Do I have any imaginary pieces to 7? 7 is real. So how can I rewrite it? Yep. But you're saying plus I, you're saying there's something imaginary in it. You're close though. 7i means the 7 is now imaginary. So Gavin was closer. 0i, good. Because I don't have any imaginary piece to that 7. So in other words, again, all of these are complex, whether you have imaginary pieces with them or not. They all can be written in a complex format. Make sense? All right. A couple of things that we want to take away from these. So a little bit of notes that we want to make with regard to our complex numbers. The first is that you can simplify the square root the same. In other words, you're still going to be taking factor trees. You're still going to be breaking them down and pulling out pairs. None of that changes. What changes is that you just pull out an I with them. Okay? The second thing that we want to make a note of is that if I equals the square root of -1, then if I have I squared, that would be the same as an I times an I. Agree? But that would be the same as the square root of -1 times the square root of -1. Now you learned last week, if I have a square root and I times it by itself, in other words, I square it, what happens? I think I heard, what did we say over here? Yeah, it goes away, right? It cancels it out. Meaning I am left with just a -1. So anytime we get an I squared, our result is actually going to turn into a negative 1. Okay, so that's the second thing that we kind of want to keep in mind. The first thing is that when you're writing this, the real part comes first. In other words, you always want to write your real numbers first. And the sort of saying that I always give for that is if you have real friends and imaginary friends, you want to make sure your real friends come first, otherwise you won't have any anymore. Okay? So real friends come first. What kind of ties directly into that is that you want to make sure that you keep the real part and the imaginary part separate. Some book keys will break this, so for us, we're going to keep them separate, but do realize that some keys will mix them. But again, the idea behind this, you want to keep your real friends and your imaginary friends separate, because if you start talking to your imaginary friends in front of your real friends, you're not going to have real friends no more. Okay, so again, keep them separated. Alright, so we have 2 examples to go through, and then we'll be done with those. Oops, sorry, I didn't ask. Were you on the...
Okay. I'm good now.
Are you sure? Example number 1. 3x squared plus 10 is equal to negative 26. The procedure for solving this is not going to be different. So what should I do here? Subtract the 10. Gives me 3x squared is equal to? Now what? Divide by 3. You must get the square alone before you square root. That is very, very important. Once that square is alone, so now I have x squared is equal to a negative 12. Now I can square root. For the sake of notes, I'm going to do this in a separate step. Remember, the moment you throw down a square root sign, what has to happen? Plus or minus. Good. Alright, so square root of x squared gives me x. I'm still going to have this plus or minus, but now I need to deal with this 12. We're going to deal with the 12 part first. What is 12 broken down into? 6?
2 and 3.
If you did the 4, 3, you get the same result. And what's the purpose of breaking that down? What am I looking for now? Right? What am I looking for?
2 pairs.
I got a pair of what?
2s.
I got a pair of 2's. So how can I rewrite the square root of 12? 2 square root of 3. But this was imaginary, right? Because of the negative 1. So you could write 2 square root 3i, but this is not really a good way to write that. Because remember what we said before. Anything with a square root, if you write it behind, it gets a little tricky as far as, is that I underneath? Is it outside of? It's kind of weird. So because of that, we're going to sort of separate this number, and we're going to write the I behind the 2, leaving the 3 still in the back. So like I said, because you have the square root there, we don't really want that I behind it, so we're going to go ahead and move it in front of it. But recognize that this 2 square root 3 is still the imaginary piece. And it's imaginary because it came out of a square root of a negative. Yeah.
Would it be the same to like write 2 and then just square 3 plus I?
No, this is not the same as 2 square root 3 plus I, because this one, they're all multiplying. This one, you're adding the imaginary inside. So this is not the same,
Just kidding.
okay? Questions on number 1 before we do a more complex one? Alright, so number 2. Side conversations need to quit. Number 2, we got 3. T minus 5 squared equals a negative 15. Remember, these are the more challenging ones because the square is a little bit more complex. So remember that as I'm looking at this thing right here is the piece that's being squared. Agree? Is that piece alone? Meaning, is that just the square, or do I have something else happening to that parentheses square? 3. I got the 3. Remember, I'm not allowed to distribute that because the square is blocking me. So how do I get rid of the 3?
Divide by 3.
Good. Divide by 3 on both sides. Negative 15 divided by 3 gives me a negative 5. Now is my square piece alone on its side.
Yes.
Yeah, I have that whole parenthesis all by itself. So now and only now can I go ahead to get rid of the square and square root both sides. You most definitely do not want to FOIL that out. That's going to make your life a whole lot harder. So on the left-hand side, I get a t minus 5. On the right-hand side, can I square root 5? No. But I do have to mark it as being imaginary because it's a negative. So remembering that we put i's in front, we're going to have plus or minus I square root 5.
So when it's a negative,
It becomes an I.
so it's positive.
Yeah, that's like what you had last week where you get positives and you get real answers. Okay? Alright, now is my t alone? No. So now what do I have to do? Add 5 to both sides. Now remember, is this 5 real or imaginary? It's real. Why is this 5 real?
There's no imaginary with it.
There's no I with it, right? I don't have an I marker. This square root of 5 is imaginary, agreed? Because I have the I. Which means that when I write this, we have to write the real number first, and then plus or minus the imaginary part in the back.
Why is the plus and minus separating them and
Because this right here is a plus or minus, so I could get either positive or negative square root, and we're adding 5 to that. So again, we would never do plus 5 in the back.
No,
because we need
like
it
on the last one you put plus or minus 2I really doesn't matter.
Yeah, it's vastly different. So plus or minus 2I root 5, this is saying I have 2 times root 5. This is saying I have 5 plus root 5. It's a different operation. So remember, the 2 came out of the square root. That's why it was multiplying with it. This 5 came from adding 5 to both sides. That's your difference. So any number in front is what you pulled out of the square root. Any number that's written as in front like this is something that you moved over. Make sense? Alright. Any other questions with that? Okay. So let me get you your assignment.